Welcome everyone. Let's discuss one of the previous year questions of GATE 2023 Biotech exam. So as you all can read, the question says an enzyme catalyzes the biochemical reaction A to B with Kcat equal to 500 second inverse. And if the initial reaction velocity, which is V0, is 10 micromolar second inverse at the total enzyme concentration of 30 nanomolar and substrate concentration of 40 micromolar, what is the value of Km in micromolar is going to be? Before answering this question, let's quickly recap few of the important terms which are mentioned in this question. We all know enzymes are mostly proteinaceous molecules, could be of RNA origin. They contain the active site where the substrate binds, undergo conformational transition, resulting in the formation of the product. One of the important thing which enzyme do is, they enhances the rate of the reaction. They enhances the rate of the reaction by lowering the activation energy. As you can see in this graph, there are two plots, one for the enzymatic reaction and the another one is for the enzymatic reaction, and you can see the change in the activation energy. You need to remember that that these enzymes doesn't affect the free energy change for a reaction, which is delta G. Let's have a look at this reaction. Is you have the E enzyme combining with the substrate, forming the enzyme substrate complex intermediate, which is converted into the product, and the enzyme is released. There are few rate constants. Forward rate constant K1, which is resulting in the formation of the ES, and then ES getting converted into the E plus P, which is represented by the rate constant K2. Also, there is a high chance that the ES gets dissociated back into the enzyme and substrate complex, which is represented by the K minus 1. Now, if we'll try to put all these terms and derive the equation, we'll get back to this equation, which is a famous Michaelis-Menten equation, which represents V naught equal to V max S divided by Km plus S. V naught is the initial reaction velocity. V max is the maximal velocity. Then you have the substrate concentration. Km is the Michaelis constant. Let's quickly go through all these terms. V max is achieved only when the catalytic sites on the enzymes are saturated with the substrate. That means all the ET, that means the total enzyme, are converted into the ES complex, which will eventually get converted into the E plus P. Vmax is represented by the K2 multiplied by total enzyme concentration, which is nothing but the ES. Km is the Michaelis constant, as I said, and it is represented by the K minus 1, the backward one, plus K2 divided by K1. Remember, the Km tells you about the affinity between the enzyme and substrate. The lower the value of Km, the higher is the affinity between enzyme and substrate. Now, this is the Michaelis-Menten plot, which is plotted based upon this equation. And as you can see, this is a plot between the substrate concentration mentioned on the x-axis, and then you have the reaction velocity on the y-axis. And as you keep on increasing the substrate concentration, there is an increase in the reaction velocity unless Vmax is achieved. And as I said, Vmax, you can calculate it via this equation, K2 into ET, which is the total enzyme, and the half of the Vmax is represented by the Michaelis constant, which is Km. And as I have said, it represents the affinity between the enzyme and substrate. Now, we need to discuss another term, Kcat, because that was given in the question. And as I have said, Kcat is also known as the catalytic constant as well as the turnover number of an enzyme. And it represents the number of substrate molecules getting converted into a product by an enzyme molecule in a unit time when the enzyme is fully saturated with the substrate. That means ES. So let's get back to this equation. I'm talking about this part, which is nothing but a Vmax only. So as you all can recall, in the previous equation, I wrote Vmax equal to K2 and then the total enzyme concentration. Now this K2 is nothing but a Kcat, which is the catalytic constant, and this also represents the turnover number of an enzyme that tells you how many substrate molecules converted into product by an enzyme molecule in a unit time when the enzyme is fully saturated with the substrate. Let's have a look at this table where it mentions about the turnover number of some enzymes. For example, carbonic anhydrase, which catalyzes the conversion of carbon dioxide and water into bicarbonate ions, has the turnover number of 600,000 per second, which is a big number. And there are other turnover numbers for the other enzymes. So this tells you that these many reaction molecules taking place per second at a given active site. Now, keeping all these things in mind, let's try to solve this question. Now, it should be easy. So what all is given in the question is Kcat value, which is 500 second inverse Kcat, or you can call it as K2. If the initial reaction velocity is given, the value is given is 10 micromolar second inverse. What else is given? The total enzyme is 30 nanomolar. We will convert it into a micromolar for our calculation. So 30 nanomolar means 30 into 10 raised to power minus 3 micromolar. Those who are not aware, 1 nanomolar is equal to 10 raised to power minus 3 micromolar. What else is given? Substrate concentration is given, which is 40 micromolar, which in this case is the A. And we need to calculate Km in micromolar. So what we can do is we can put all these values in this equation. V naught equal to Vmax as Km plus S. V naught is given, S is given, Km I need to calculate. Vmax is not given, but that should not be a problem because I can calculate the Vmax. Because as just discussed, Vmax is equal to K2 into K2 or Kcat into total enzyme concentration. So the Vmax is going to be Kcat into total enzyme concentration. Kcat value is given, which is 500 second inverse, and then total enzyme concentration 30 into 10 raised to power minus 3 micromolar, and we'll solve it. You'll get 15 micromolar second inverse. Simple. Keep all these values here. So what we can do is V naught Vmax S by Km plus S. V naught, go back and read it. These values are 10. V naught value is 10. Vmax just now we have calculated is 15. Substrate concentration for A reactant is given 40. Km I need to calculate. S is again going to be 40. We can rearrange this equation and this will come out. This is going to be rewritten as Km plus 40 equal to 15 into 40 is equal to 600 divided by 10. I have just interchanged it. Now Km value is going to be how much? It is 60 minus 40 equal to 20 micromolar. Simple. I hope this solution is clear to each and every one of you. If not, let me know in the comment section. Thank you very much.